Okay, so here today we will discuss linear independence and dependence of vectors. Okay, so let v1 v2 etc vn be vectors, then the expression alpha 1 v1 plus alpha 2 v2 plus etc alpha n vn, where alpha 1 alpha 2 etc alpha n are scalars, is called linear combination of vectors. For example, if you take I will give you an example. If I take v1 is equal to, first vector is 1 0, second vector is 1 2, then then 2 into 1 0 plus 3 into 1 2. This is a linear combination of 1 0 and 1 2. This is an example for linear combination. Now that means a scalar times that vector plus again scalar times that vector. So that means here this is v1 v2 alpha 1 alpha 2. So alpha 1 is here 2, alpha 2 is 3. So this is an example. Now the important part is, suppose alpha 1 v1 plus alpha 2 v2 plus etc alpha and vn is equal to 0, happens only when alpha 1 equal to alpha 2 equal to etc alpha n equal to 0. Then the vectors are called linearly independent. Then the vectors are linearly independent. That means if you have any linear combination alpha 1 v1 plus alpha 2 v2 etc alpha and vn, this happens only when all alpha is are 0. Then we say those vectors are linearly independent. If any alpha I not equal to 0, then we say linearly dependent. So for I will give you some example. For example, if I take first example, v1 is equal to 1 0 1, v2 is equal to 2 0 2, v3 is equal to 0 0 1. Okay, can you tell this, is this vector is linearly independent or dependent directly? So this is v1, this is v2 and v3. Can you find a linear combination those and equate it to 0, where some of the scalars is non-zero? Anybody? v1 v2, a linear combination of v1 v2 is equal to 0. So if I take okay, I will take a linear combination like this: 2 into 1 0 1, for example, minus 1 into 2 0 2 plus 0 into 0 0 1. So what happens this linear combination? How to multiply a vector and a scalar? So 2 into 1 0 0 means 2 0 2 plus minus 2 0 minus 2 plus, we will multiply coordinate with 0 0 0. So what happens is, how to add 2, okay, 2 plus, we will add coordinate with 2 minus 2 plus 0, and what will happen here? 0 0 0, and we will add coordinate with 2 minus 2 plus 0. So what will you get? 0 0 0. So that means this linear combination, when we is equal to 0, right? So what are the scalar? 2 minus 1 0. So here this is not equal to 0, this is not equal to 0, still the combination is equal to 0. So what you can tell about these vectors? Is it linearly independent or dependent?
Dependent.
Independent.
Linearly dependent ആണോ independent ആണോ dependent ആണോ?
Dependent.
Dependent, because why it is dependent? Because we have 2 and -1 are non-zero, right? Non-zero. As few of the alphas are are non-zero, still we get the linear combination is 0. So this is linearly dependent. Okay, now I give another example. V1 is equal to 1 0, V2 is equal to 0 1. Tell me, is it linearly dependent or independent? So you check whether alpha 1 V1 plus alpha 2 V2 is equal to 0 0. So what happened? Alpha 1 into I want to check
Sir,
whether, okay, tell me.
sir, can you use another color because the color is not.
Okay, okay. So alpha 1, so I will write once more. So I will give you another example. Example 2. V1 is equal to 1 0, V2 is equal to 0 1. We have to check whether it is linearly independent or not. That means whether there is some alpha 1, alpha 2, etc., such that their linear combination is equal to 0 where alpha is non-zero. So for that I will check alpha 1 V1 plus alpha 2 V2 is equal to 0 0. So alpha 1 into 1 0 plus alpha 2 into 0 1 is equal to 0 0. Now what will happen is alpha 1 0 plus 0 alpha 2 is equal to 0 0. So which implies so this is equal to, which implies what will happen if you add these two vectors? Alpha 1 alpha 2 is equal to 0 0. So what you get? Alpha 1 equal to 0, alpha 2 is equal to 0. So in this case, if you take any alpha 1 and alpha 2, whatever alpha 1 and alpha 2, if you equate it 0, there is only one possibility: alpha 1 equal to 0, alpha 2 equal to 0. Then what you can tell about these vectors? Is it linearly independent or dependent?
Linearly independent.
So the thing is, what is the problem here? The problem here is how to identify if you have more than 3 or 4 vectors, how to check whether the vectors are linearly independent or not. So it is not very easy, right? By guessing or by trial and error method, it is not, it will be very time consuming and cannot easily find the answer. So there is so there we use matrix. So now our first problem is check whether the vectors 1 2 1 2 1 4 4 5 6 and 1 8 3 are linearly independent in R3. R3 means if you R3 is simply means R cross R cross R. Okay. Anybody have any doubt? That means this is elements in this R3 is in three tuple. First coordinate R1, R, second coordinate R. So all real numbers. Okay. In general, R R2 means R2 elements in R2 is tuples, two tuples. Okay, 1 2 is an element of R2, that means R cross R. Okay. So we have given the vectors in R3 and we have to check whether these are linearly independent or not. So there is a shortcut method. So that method tells us what we have to do. If you have a vector v1, v2, v3, etc., vn, n vectors, if there are n vectors, then first step is form the matrix with these vectors as raw vectors. Form a matrix with these vectors as raw vectors. Second, find the rank of this matrix. So first you have to form a matrix with raw matrix with these vectors as raw vectors, then find rank. Third, if rank equal to n, n means number of vectors. If rank equal to number of vectors, then the vectors are linearly independent. If rank is less than number of vectors, then the vectors are linearly dependent. So now we will do first problem. So what is this step one? How to check the vectors as linearly independent or dependent? First you write a matrix whose rows are the given vectors. Okay, then you find the rank. If rank equal to number of vectors, then linearly independent. If rank is less than number of vectors, then linearly dependent. Okay, so now we will do this problem. So what is the first step? So these are the vectors, right? So what is the first step? You tell me. So we will do this problem first. Okay, this problem, is it visible? Are the following set of vectors are linearly independent? Show the detail. The first problem is 340 2137 16 minus 12 minus 22. So first solution. So I am doing 17. So what is the first step? I will write A equal to the vectors as raw vectors, right? So what is first row? First row
3402.
3402, right? Second row 2
2 minus
minus
137.
137. 116 minus 12 minus 22. Now what is next step? So how many vectors, number of vectors is equal to how many vectors are there?
3.
Three vectors.
3 vectors. Now you find out the rank. So how to find out rank? Find row echelon form. So what is the first pivot?
Three.
So you can write that row as. Now I have to convert R2 converted into R2 changes to 3
3R2
3
minus
R2 minus
2R1.
2
R1, right? So what will happen here? 0 minus 3 minus 8, right? Minus 3 minus 8. What is here? Minus 11. What is next value? Hmm? Next value, is it 9? 3 into 3, 9, minus 2 into 0. What is next value? Here, here, 3 into 21 minus 4,
17.
7. So now you have to convert this into 0. So what is the operation? R3,
minus R.
3
R
R
minus
minus
R1.
R1.
R3 minus R1, right? So this is 0. What will happen here? 3 into 16. 3 into 16, 48 minus 4.
44.
And minus 3 into minus 12. Minus 36.
36.
Minus 0. So minus 30. Now what will happen here? Minus 3. 3
16.
into is minus 66 minus 7. What is that? Minus
68.
8.
sir,
Okay, tell me.
minus
This is
60.
Minus
Minus
68.
Q.
Minus
Minus
68.
68, sir.
minus 68. Sorry. So minus 66 minus 2, right? Minus 68. Correct. Now what is next pivot? Minus 11, right? So we will write 3, 4, 0, 2, 0, minus 11, 9, 17. Now I want to make this here. So what is R3? What is the operation?
R3 minus 4 R2.
Plus
4 R2. R3 plus 4 R2, right? Here there is minus 11. Then this becomes 0. What will happen here?
0.
0. Here
0.
0. No? 4 into 17, 34, 15. 0, right? Okay. So what is the rank of A? How many non-zero rows are there?
2.
2.
2. So 2. How many vectors are there?
3.
3. So this is strictly less than 3. So what you can tell about these vectors? Is it linearly?
Dependent.
Linearly dependent. Now you do this problem. 18th problem. Is it visible?
Yes, sir.
Yes, sir.
Yeah, I will zoom. Now it is clear, right? So do this problem. 18th problem.